We take the rhythm of our world completely for granted. We wake, we work, we sleep, and the background track to all of it is a steady, predictable spin. Beneath our feet, the Earth is hurtling through the vacuum of space, rotating on its axis at roughly 1,000 miles per hour at the equator. You do not feel it because you, the atmosphere, the oceans, and everything you have ever known are moving right along with it, locked in a perfect, cosmic embrace of momentum. It is a seamless illusion of stillness. But what if that illusion shattered? What if, for a duration so brief you could barely take a breath, the machinery of the cosmos simply jammed? What if the Earth stopped spinning for exactly 5 seconds? To understand the absolute apocalypse of those 5 seconds, we have to look at the invisible forces holding our reality together. Right now, your body is adjusted to inertia. If you are in a car and the driver slams on the brakes, you fly forward. Your body wants to keep moving at the speed the car was traveling. Now, scale that up from a highway speed limit to a planetary scale. The planet is spinning eastward. Everything on it, the skyscrapers, the mountains, the soil, the trees, and every living creature, shares that eastbound momentum. If the solid rock beneath our feet came to a dead, sudden halt, the laws of physics would not care that it was only for 5 seconds. The law of inertia dictates that an object in motion stays in motion unless acted upon by an outside force. The sudden stop applies only to the crust of the Earth. It does not apply to the things resting upon it. The transition would not be heralded by a siren or a warning. It would happen in an instant too small to measure. In the very first second of the stoppage, the world as we know it would be torn to shreds. Imagine standing in a major metropolis sitting right on or near the equator, where the rotational speed is at its maximum of 1,000 miles per hour. The moment the crust stops moving, everything not anchored deep into the planetary bedrock continues to move eastward at 1,000 miles per hour. To put that into perspective, a Category 5 hurricane brings winds of 150 miles per hour. The force unleashed in this first second is more than 3 times more powerful than the most devastating tornadic event in human history, and it happens everywhere, simultaneously. Human beings would not simply trip or fall. At 1,000 miles per hour, the human body effectively becomes a projectile. If you were indoors, you would be launched into the eastern wall of the room with enough kinetic energy to mimic the impact of a high-speed jet crash. If you were outdoors, you would be hurled horizontally across the landscape, flying through the air until gravity or an obstacle claimed you. The buildings we call home, built to withstand vertical gravitational pressure and standard lateral wind forces, would fail instantly. Glass skyscrapers would explode outward, their fragments transformed into a supersonic cloud of razor-sharp shrapnel traveling east. Concrete and steel structures would shear off at their foundations. Entire cityscapes would look as though a giant broom had swept across the surface of the Earth, leveling every home, office, and monument in a single, horizontal stroke. The most terrifying element of this first second, however, is the atmosphere itself. The air we breathe possesses mass, and like everything else, it is moving at 1,000 miles per hour. When the planet stops, the atmosphere keeps going. This creates a global windstorm of unimaginable proportions. The air pressure would spike violently. The sound alone would be a roar so loud it would rupture human eardrums instantly. This supersonic wind would scrape the surface of the Earth clean. Soil would be ripped from the ground, trees would be uprooted and turned into missiles, and the very topography of our landscapes would begin to blur. As the clock ticks to the second, the liquid components of our planet join the chaos. The oceans, which contain the vast majority of the Earth's water, are subject to the same laws of inertia. For millions of years, these massive bodies of water have been sloshing within their basins, held in place by gravity and the steady rotation of the Earth. When the basin stops, the water does not. A wall of water thousands of feet high would detach itself from the western coastlines of every ocean basin and surge eastward. Atlantic waters would rush over Europe and Africa. The Pacific Ocean would throw itself across the Americas with a weight that defies comprehension. This is not a standard tsunami triggered by a localized earthquake. This is the entire volume of the world's oceans moving with the kinetic energy of a planetary stop. Coastal cities that survived the initial wind blast would be erased beneath a churning mass of seawater within moments. The water would travel inland for miles, moving at hundreds of miles per hour, carrying with it the crushed remnants of ships, ports, and coastal infrastructure. Meanwhile, a different kind of horror is unfolding away from the equator. As you move north or south toward the poles, the rotational speed of the Earth decreases. At the poles themselves, the speed is practically zero. Therefore, the violence of the inertia is a gradient. If you were standing in northern Canada, Scandinavia, or the southern tip of Argentina, the wind speeds and the throwing force would be significantly less, perhaps only a few hundred miles per hour. Yet, these regions would face an entirely different crisis. The Earth is an oblate spheroid. Because it spins, centrifugal force bulges the planet out at the equator. The oceans are pulled toward the middle of the world, creating an equatorial bulge of water. The moment the rotation stops, that centrifugal force vanishes. The water that was once held at the equator by the spin of the Earth suddenly wants to redistribute itself. It begins a violent, massive migration toward the poles, where gravity pulls it more directly. Even as the eastward inertia sloshes the ocean sideways, a secondary, north-south surge begins to take shape, threatening to drown the polar regions under thousands of feet of water while draining the equatorial seas. By the third second, the violence penetrates deep beneath the surface. The Earth is a layered sphere with a brittle crust floating on a semi-fluid mantle, which surrounds a liquid outer core and a solid inner core. When the solid crust is forced to a sudden halt, the immense friction between the crust and the moving mantle beneath it creates an apocalyptic amount of stress. The tectonic plates, which usually grind against one another at the agonizingly slow pace of centimeters per year, are suddenly subjected to forces billions of times greater than normal. Fault lines would split open, creating massive chasms that swallow entire landscapes. The ground would ripple like waves on an ocean as the kinetic energy travels through the rock. This immense subterranean pressure would instantly trigger every active and dormant volcano on the planet. Magma reservoirs, squeezed by the sudden shifting of the crust, would blast through their volcanic vents. Supervolcanoes like Yellowstone, Long Valley, and Toba would be violently cracked open, venting plumes of ash, toxic gas, and molten rock into an already chaotic atmosphere. The sky would begin to darken with a mixture of pulverized soil, debris, and volcanic ash, turning day into a hellish, bruised twilight. By the fourth second, the consequences move beyond the physical ground and water, reaching into the invisible forces that protect life on Earth. Our planet is enveloped by a powerful magnetic field, the magnetosphere, generated by the movement of liquid iron and nickel in the outer core. This magnetic shield is our only defense against the relentless stream of deadly radiation emitted by the sun, known as the solar wind. When the planet stops spinning, the delicate balance of this internal dynamo is thrown into absolute chaos. While the outer crust has stopped, the liquid core continues to swirl and churn independently. This sudden disconnect would disrupt the electrical currents generating the magnetic field. The magnetosphere would fluctuate wildly, weakening to a fraction of its normal strength. Without this steady shield, high-energy solar particles and cosmic rays would begin to penetrate deeper into the atmosphere. The sudden influx of radiation would trigger massive electrical disruptions, instantly frying global power grids and communication networks. At the same time, the atmospheric pressure changes would reach a critical peak. The air that was shoved eastward would begin to compress against geographical barriers like the Rocky Mountains, the Andes, and the Himalayas. This compression would create areas of ultra-high pressure on the western slopes and near vacuums on the eastern slopes. The temperature of the compressed air would spike, igniting spontaneous wildfires, while the vacuum zones would experience a sudden, freezing drop in temperature. The fifth second is the apex of the stillness, the maximum point of dislocation. For one fleeting moment, the planet stands completely still on its axis. If an observer could look down from space, the Earth would be unrecognizable. The familiar blue and white marble would be obscured by a thick, swirling shroud of brown dust, gray ash, and white water vapor. The outlines of the continents would be blurred as the oceans continue their violent migrations. The lights of humanity's cities would be entirely extinguished. In this fifth second, the sheer scale of the ecological collapse becomes absolute. The habitats of every living creature have been disrupted or destroyed. Marine life in the shallow coastal waters has been flung inland or left stranded. Birds in mid-air were caught by supersonic winds, their bodies unable to cope with the sudden turbulence. The world is a chorus of roaring winds, crashing waters, and the deep, low-frequency groan of a fracturing crust. It is a world where the natural order has been completely upended in less time than it takes to read a sentence. Then, the 5 seconds are over. The cosmic jam clears, and the Earth abruptly resumes its rotation, spinning eastward once again at 1,000 miles per hour. You might think that the return to normal would bring relief, but physics does not work that way. The sudden restart is just as violent as the sudden stop. It is a second, catastrophic shockwave that hits a world already brought to its knees. When the crust suddenly jerks back into motion at top speed, everything that was currently flying eastward or sloshing inland is subjected to a reverse force of inertia. The air is suddenly met by a crust moving at the same speed beneath it, creating a secondary wave of supersonic turbulence as the atmosphere tries to resynchronize with the planet's spin. The oceans are suddenly jerked backward. The water that had rushed across the land now crashes back into the ocean basins with equal violence, carrying with it millions of tons of debris, soil, and the remnants of the old world. This backwash would create secondary mega-tsunamis that scour the eastern coastlines, ensuring that whatever survived the first assault is utterly destroyed. Hours pass, then days. The immediate violence of the stop and start begins to subside, but the world that remains is a haunted, scarred version of its former self. The human cost would be near total, claiming the vast majority of the global population in the first few minutes. The survivors would find themselves in a world without infrastructure, without power, without clean water, and with an atmosphere that is deeply hostile to life. The long-term environmental consequences would unfold over decades. The sheer volume of volcanic ash and dust thrown into the atmosphere would trigger a severe volcanic winter. The sun would be obscured by a thick, global haze, causing temperatures around the world to plummet. Photosynthesis would grind to a near halt, leading to the collapse of plant life and the starvation of surviving herbivores. The food chains of both land and sea would be shattered, forcing a mass extinction event. The geography of the planet would be permanently altered. The shifting of the tectonic plates would have raised new mountain ranges and sunk existing land masses. The equatorial bulge of the Earth would take time to reform, causing long-term adjustments in the planet's shape and gravity field that would manifest as ongoing earthquakes for generations. Why does the Earth spin in the first place? It is a legacy of our solar system's birth. Some 4.5 billion years ago, a massive cloud of hydrogen gas and interstellar dust began to collapse under its own gravity. As it collapsed, it began to rotate, much like a figure skater pulling in their arms to spin faster. The planets, including Earth, coalesced from this swirling material, inheriting their spin from the original rotation of the cloud. Because space is a near-perfect vacuum, there is virtually no friction to slow the Earth down. It has been spinning on its celestial bearings for eons, slowing down only minutely over hundreds of millions of years due to the gravitational drag of the Moon. But a sudden breaking event is completely alien to the cosmic routine. Air is flexible and fluid, but when pushed to supersonic speeds, it behaves like a solid wall. As the air masses slam into towering rock faces, the temperature would rise instantly by dozens of degrees due to adiabatic compression. On the opposite sides, the sudden vacuum would drop pressures to near-zero levels, causing a sudden boiling of unpressurized liquids. Water, too, would act as a planet-scale hydraulic mining tool, stripping away hundreds of feet of topsoil and bedrock within seconds. Consider the layout of our global infrastructure. We build nuclear power plants near coastlines, we build chemical refineries at shipping ports, we build dense urban centers along major tectonic fault lines. In the event of a 5-second stop, every single one of these systems fails simultaneously. Nuclear facilities would be inundated by oceans or ripped apart by supersonic winds, leading to widespread cooling failures. Chemical plants would rupture, spilling industrial toxins into the churning global floods. There would be no communication, no coordination, and no rescue. The geopolitical and biological maps of the world would be redrawn by the hand of pure physics. Polar regions would be overwhelmed by a deep, cold, and relentless oceanic inundation, as the water level at the poles rises by up to several kilometers while the equator experiences a drastic drop in sea level, exposing vast tracts of new, muddy land valleys that were once the floors of the Atlantic and Pacific Oceans. The ultimate takeaway of this scenario is a deep, humbling realization of our place in the cosmos. We live our lives within a narrow corridor of environmental parameters that we treat as permanent constants. We assume the air will always be breathable, the temperature will stay within livable bounds, and the ground will remain a solid platform for our ambitions. We treat the rotation of the Earth as a background detail, a clock that simply marks the passing of our hours. But it is not a background detail. It is the core mechanism of our survival. The spin of our planet distributes the sun's heat evenly across the globe, generates the magnetic umbrella that protects our atmosphere, and keeps the oceans stable within their geographic boundaries. We are an integral part of a complex, dynamic planetary machine that is currently spinning through a cold and indifferent void at incredible speeds. The delicate architecture of human society, our art, our cities, and our scientific achievements are all fragile constructs built upon the steady, reliable physics of a spinning world. If that spin ever falters, even for the length of a single human breath, the sheer power of planetary momentum would erase our presence as easily as a wave washes a footprint from the sand.